Hi, this is the second part of the proof of the existence of the non-trivial solution of Pell's equation. So we already know that for some integer d, there exist infinitely many solutions, integer solutions of the equation x squared minus ay squared equal to d. Now, consider possible remainders of x and y modulo d. We understand that there are finitely many combinations of such remainders. Rx denotes the remainder of x, Ry denotes the remainder of y, and all in all, there are d square possible pairs of remainders. Pick d squared plus 1 points. Since there are infinitely many points, we can for sure pick d squared plus 1 of them. And now we can use the famous pigeonhole principle, from which it will follow that indeed two of the points will belong to the same pair of remainders, which means that it will belong to the same whole as in pigeonhole principle. But using the terms of congruence modulo d, it will follow from this that x1 is congruent to x2 and y1 is congruent to y2 modulo d. And this is what we needed in the second step of the proof. In the next video, you will see the third, final step of the proof, and just a small remark concerning this final step. For now on, we have proved that some statements hold for an integer d. And in the final part, we will use a positive integer d. Well, I just want to say that it doesn't matter. Everything that will be said about positive integer d will also hold for a negative integer d, and of course d cannot be equal to 0 since a is not a square, and if x squared minus ay squared would be equal to 0, then both x and y should be equal to 0. Therefore, in the next fragment, we will deal with a positive integer d, and I invite all of you to proceed to the grand finale.